Okay, well, so good evening, good afternoon, sorry, good afternoon, students. So today we are going to discuss about the other topic of power plant engineering. Already we were discussed about four different areas. That is, up to we covered four units, and the last few classes we discussed about the fifth unit. Okay, related to power plant design. Okay, in that we were discussed about what is the main aspects of power plant design, what are the factors we have to consider. Then we discuss about what are the different type of pollution occur in power plant, either maybe a thermal power plant or maybe a nuclear power plant. What are the different type of pollution maybe happen, how to control that pollutions, everything we were discussed. So in this class we are going to discuss about power plant load, and already we touch upon some areas of power plant load. Okay, different type of loads we already touch upon. Okay, just a review of the power plant load, then we'll move to the next topic is terms and factor of power plant load. Okay, so that is we are going to discuss today, right? Now we'll move to the class. So the today agenda of the session is going to be first discuss about the different types of load. Okay, and next we are going to discuss about in depth of terms and factors of power plant. Okay, so already we discussed types of load. Anybody have an idea what are the different type of loads we were discuss? So in this slide you can see different type of load. Anyone please tell what are the different type of loads we were discussed? Venkatraman, you have any idea what are
Yes,
the different
sir.
type of loads we were
Residential,
discussed? Yes, okay.
commercial, industrial, municipal, irrigation, and
Yes.
traction load.
Okay, so these are the different type of loads we were discussed. So residential load is nothing but power used for residential purpose, or for example, sorry, for example, for domestic lights, okay, in the houses, and such as radios, TV, water heaters, refrigerators in the homes usages, everything is comes under residential load. So in the home we use several instruments for domestic applications. Okay, so that all load is comes under residential. Next we are going to discuss about commercial. What is commercial? So normally for commercial purpose, like for advertising the shop, okay, some lightning is required, some operations, okay, in the restaurants of menus, something like that. Okay, so we use some commercial purpose for the power. Okay, these all are comes under commercial load. Next one is industrial. Industrial load is exclusively the power utilized for industry purpose. Okay, for manufacturing. Similarly, production. Okay, processing. Okay. For example, manufacturing means some component maybe they produced. Okay, turning, milling operations may be required. Some stamping, some whatever. Okay, it's requirement. Okay, the machines are used for doing that operation. So for operate a machine, a power is required. So that all comes under industrial load. Similarly, in the way of production. Okay, so if you want to produce some uh, domestic usage purpose or industrial purpose. Okay, some component may be used for some purpose. Okay, so either maybe a individual persons or maybe a societal use or whatever it may be. Okay, so maybe a product is manufactured or produced mean that is also comes under industrial code. Okay, and similarly uh, process industries like but paper industries, textiles processing. Okay, all those load all comes under industrial. So what I'm trying to say is the power used for processing or production or manufacturing, that everything is comes under industrial load. Next, municipal load. So municipal purpose, some street lighting, okay, some water supply, drainage purpose, okay, some power required, some amount of power is required to, okay, facilitate these things. Okay, that is street lighting, power, water supply for homes and public places. Okay, So these all are okay operated based on the municipal or maybe a town panchayat okay boards okay. So with help of that boards okay they use the power okay for street lighting and water supply and drainage purpose. So these powers can be used okay for various municipal work purpose. So these load are called as municipal load. And next one is irrigation. So irrigation means water is required for agriculture. Okay. So without water, we cannot cultivate the land, and the growth of the plant is depending upon water. So water should be pumped from well source or from some areas that is water dam sources. Okay, the water should be pumped and sent it to the agriculture area. So you need some pump or electrical motors. Okay, to supply the water. Okay, so automatically okay if you want to operate a pump or motor means okay you need electrical power. So that power is all are called as irrigation load purpose. Okay, so that power can be used for agriculture irrigation purpose. So that type of power requirement we can call it as irrigation load. And the final one is traction load. So nowadays we use e-vehicles, that is electric based vehicles. Some trolley and buses are also now operated based on electric vehicles. So electric vehicle, if you want to use means we have to charge the battery. So the battery is charged with help of electric energy. So the energy is required to charge the battery. So that type of loads are called as traction load. So by this application, okay, by the different application, we are classified the requirement of electricity in different categories. Okay, that all called as load. Okay, so load is nothing but electrical requirement. So based upon the uses, we are categorized into six types of load: residential, commercial, industrial, municipal, irrigation, and traction load. So I think we are already discussed about what is meant by load, and load curve also we will discuss. So load curve is nothing but approximately we use different type of purpose. Okay, the load may be varied from time to time. Okay, approximately it varied. Okay, for morning it may be require more power, maybe require more. Afternoon it may be require less, and evening time it may be require more. Okay, because night time okay lightning purpose all the houses uses electric energy. So morning to afternoon time maybe the house domestic purpose of electricity is maybe less. So according to the requirement, okay, we can draw a curve, okay, or we can draw a graph, okay. So that curve is called load curve. So with respect to time and load, okay, how much power is required, okay. So say an example from 12 a.m. to 12 p.m. Okay, what will be the power requirement? Okay, so in the evening time, how it is raised. Okay, in the morning time, how it is raised. Okay, so based upon the variation, okay, we can say okay which time okay domestic time domestic purpose is increased, or industrial load may be increased only in the daytime. Okay, and night time most of the industries are closed. Some industry may be work on shift basis. That time night time may be increased. So based upon that we can calculate the load requirement. So power requirement base we can identify. So what will be the requirement of the power in that particular place? So how much power we have to develop with help of the power plant? So how we can compensate? Okay, if it is any shortage, how we can compensate, or how we can increase the power production? So based upon that, okay, we can decide. Okay, so based upon these curve only, we can able to decide the thoughts. Okay, we can create some thought, or we can create some other power plant, or some decision we can take. Okay, based upon the curve. So load curves play a very important role. Okay, so based upon the load curve only we can take up some decision. Okay, so what will be the power requirement? So load curve is nothing but a graphical representation. It is drawn between time and the load. Okay, so that is you have to keep it in mind. Okay, so there are different type of load curve is there. One is residential load in street lighting, urban traction, industrial. So based upon various applications, we can draw a load curve. Okay, we discussed six different type of load: residential, commercial, industrial, municipal, irrigation, and traction. So based upon that, we can calculate we can able to draw a different type of load curve. Residential load curve can, residential load curve can be drawn. Similarly, commercial load curve. Similarly, industrial. Likewise, different type of load curve we can draw. Okay. So if you want to, simple ideas, if you want to mm, draw a load curve, means you should know what will be the load, okay, and what will be the time duration. So if you know these two things, okay, for example, between 12 to 12, okay, what will be the power requirement? Based upon the load, we can able to draw the curve. So with help of the curve, we can able to decide some thoughts, okay, or we can decide, okay, how much will be the requirement of power. So how we can tackle the situation, all those things we can decide, right? So this is about load curves. Next one is called load duration curve. Load duration curve is simply a rearrangement of daily load curves. So normally, load curves are normally drawn for time basis. So time means, okay, it is between 12 to 12. That means morning 12 to night 12. Okay. So that means, okay, we can able to predict only one day. Okay. So what will be the power requirement in a day, that will be decided based upon load curve. But here you can see load duration curve means with a period of time. Okay, what will be the uh, load requirement. So based upon the descending order, or we can say based upon the magnitude. Okay, okay, based upon the power requirement. Okay, so some in the morning time maybe power is required high, and evening time also power requirement is high. So based upon the requirement or peak load conditions, okay, we have to draw up the load duration curve. So based upon the descending order wise, the load curve is drawn with the duration. So morning from 12 to 12 to midnight, 12 to 10 o'clock. Okay, higher peak power is required. After 10 to 4, the amount of power is very minimum. Again, 6 to 12, the amount of power is increased. Means, okay, we can divide, okay, into separate, different, okay, categorized, okay. So, which time the power requirement will be more, and which time the power requirement is very less, which time the power requirement is moderate. Likewise, we can segregate it, and based upon that, the duration, okay, that will be mentioned in terms of descending order. Okay, so based upon that, we can able to draw that curve is called load duration curve. So if it is in descending order, okay, in the time, okay, that curve is called, okay, there is load duration curve. Okay. So next we are going to discuss about different terms and factor. Okay, this is the today agenda. So now we are moving to today agenda, that is terms and factor. So up to this we are discuss about different type of load. Okay, so now we are moving to different terms and factors related to power plant load. Okay, first one is connector load. So what is mean by connector load? Means connector load is the sum of rating in kilowatts of equipment installed in the consumer premises. For example, if a consumer, okay, for example, in a house, okay, you may be use tube light, you may be use heater, you may be use TV, you may be use tube light, you may be use CFL bulb, you may be use in ironing of in in a home, and similarly fan also may be used. Okay, so for an example, in a house, these all if you want to operate means a power is required. Okay, so if you want to calculate a connector load, means you have to add all the sum of the uh, equipment's loads. Okay, so tube light may be required 40 watt, a heater may be required 1000 watts, a TV if you want to uh, use means a 60 watt may be required, tube light means 40 watt, CFL bulb if you use means the house means 20 watts is required, Iron box is if you use in a house means 500 watt is required. Another CFO bulb is used 25 watts is another required, and fan 60 watt. So these are the different equipment is available in your home means if you want to calculate the connector load means, so each equipment what will be the maximum load that can be utilized, that can be calculated. So likewise tube rate 40, heater 1000, likewise you have to calculate, and you have to add all the loads. Okay, so 40 plus 1000 plus 60 plus 40 plus 20, 50 plus 500 plus 25 plus 60. So if you add all those things, that will be a total sum of the load, that is called connected load. So total sum of the load is nothing but in a consumer premises. So any house or maybe industry or whatever it may be. Okay, so many component may be used for different applications. So if you want to operate that component means you need power. So each power requirement of the component should be calculated. Then you have to add all the components power load. Okay, then you can add it means that will be a total load. So by this way a connector load can be calculated in each area. Okay, so likewise if you want to connect a total connector load means, okay, in particular area, for an example I told in the last class, if you want to calculate the connector load in particular area, say an example Kodavadi means, okay, in our college location means, okay, all the houses, okay, how many houses is there? Around 60 houses is there, man. In that 60 houses, each houses how many watts may be used, okay, that will be taken out. Okay, and you have to add all the 60 houses to your power requirement. Okay, if you add means you will get one answer, that will be a connector load for the particular premise. Likewise, okay, each area, okay, or each places, okay, consumer premises, you can calculate the connector load. Based upon the connector load, okay, you can calculate the load requirement in particular area. So based upon that, you can supply the power from the power plant to the, okay, power station. Then power station will deliver the power to the particular area. Likewise, we can tackle the situations. Okay, so the load requirement, if you want to calculate means, okay, you should know the connector load first. Okay, so you get my point. What is meant by connector load? Any doubt in this connector load, students?
No doubt, sir.
Okay, next we are moving to demand. So what is meant by demand? Demand is nothing but, okay, if you know the connected load means you can able to express the demand, because each okay, consumer use some amount of energy. Okay, so if you add, okay, all the consumers energy means you can able to tell what will be the demand. Okay, so the demand of an installation or a system is the load of that drawn from the source of supply at the receiving terminal, average over a suitable and specified interval of time. So demand is expressed in kilowatt or suitable unit. So now what is meant by demand means? Demand is nothing but, okay, the power source is supplied from the power station. So based upon the power supply, okay, so power receiving from the terminal average, okay, in a period, okay, in an average particular in time interval, what will be the, how much, what will be the power supply, or how much source of power is received, okay, from the source area, power source area, that is called demand. Okay, so based upon the demand only we can, okay, supply the power to the consumers. Okay, so if you know the connected node, then you can verify the demand. Okay, based upon that you can tackle the situation. Okay, if your demand is high means your connector load will be very low means that is no issue. If your demand is, okay, more, that means you have to supply more power, because connector load is, okay, more and demand also more means you have to supply more power from the power station. Okay, so you have to increase the power production. Okay, that is the main thing. Okay, so for simply we can say demand is nothing but the requirement of power. Okay, arise by the consumer, and based upon that, okay, for a particular time being, how much amount of supply power is received, okay, from the power production area. That is called demand. Okay. Next, maximum demand or peak load. So peak load, you know, it is the nothing but the maximum load which consumer uses at any time. So in between night 12 to morning 12, or we can say midnight to midnight. Okay, midnight 12 to then very next day midnight. Okay, so between the 12 to 12, okay, that is 24 hours time, the consumers may be use a maximum uh, power. Okay, on a particular time the consumer may be use the maximum power. That is called peak load. Okay, so it can be less than or equal to connector load. So you have to always, okay, keep it, this is a formula, it should be less than or equal to connector load. If your connector load is increased, mean, okay, you cannot able to supply, you can connector load is less means you can easily supply. If connector load is more, means you are not able to supply the power according to the requirement. Okay, or maybe your connector load is equal, means you can easily supply. Okay, so always you have to think, okay, it should be less than or equal to the connector load. So most of the time you have to maintain, or most of the time, not we can say, we can always maintain it should be less than or equal to connector load. Okay, so peak load is something but maximum load consumer may be used at any time. Okay, if all the equipment fitted in the consumer premises run their fullest extent simultaneously, then the maximum demand will be equal to connector load. எப்போ வந்து நமக்கு that will be connector load and your maximum load will be equal na, the consumer may be used. For an example, in a house we use different instruments. Okay, tube light, heater, TV, tube light, CFL bulb, ironing, CFL bulb, fan. These are the things may be used in a house. Okay, these are the instrument. If you want to use this instrument, mean power required. Okay, in our customer maybe used all the instrument at particular time, means, okay, that time only our peak load will be arise. Okay, so when the peak load is arise, means simultaneously all the instrument may be used, mean then only peak load will be arise. Okay, otherwise peak load will not be arise. So this is the case for peak load. Okay, arise. Okay, so when peak load is arise, means a consumer may be used all the power, all the equipment at fullest extent simultaneously. Then the maximum demand will be equal to connector load. Appo the connector load will be equal. Okay, but generally all the maximum demand is less than the connector load because all the devices never run. So in general practice, most of the time all the instrument may not be used at a time. Okay, எல்லா டைம்லயும் இருக்காது. Okay, so generally வந்து பாத்தீங்கன்னா connector load uh, uh, always is lesser. Okay, less than the connector load. Maximum demand is less than the connector load because all the devices never run at full load at the same time. At the same time, it's not at all possible to operate all the instruments simultaneously. Sometimes definitely one or two instrument may not be used. Okay, so but in some very extended cases, okay, may be used. All the instrument may be used at a time. That means simultaneously used. That time the peak load may be arise. Okay, so these are the things you have to keep in mind for maximum demand or peak load. Next factor is load factor. So what is mean by that load factor is, load factor is defined as the ratio of average load to the peak load. So you know what is mean by average load in a particular time interval. Okay, based upon the consumer usage. Okay, you can tell what will be the average load. Okay, so from for example from January to December. Okay, so each month you maybe need, okay, some amount of power. Okay, so based upon that, if you want to calculate the average bills, you have to add all the month load requirement, then you have to divide by 12, then you can calculate the average. Okay, so that is the average load. Okay, and peak load, some time maybe higher amount of power and power may be used. For example, in the May month, okay, due to the summer, okay, the power requirement may be rise in between from January to December. Okay, so the maximum peak load may be arise on May month. Okay, so if you want to calculate the load factor, means you want to use okay these two data based upon the ratio we can calculate. We can able to find the load factor. So load factor is nothing but the ratio of average load to the peak load. Okay, so during a certain prescribed period of time. So based upon the prescribed period of time. Okay, so you have to take it prescribed time. Okay, so January to December, or from uh, from morning, sorry, from night 12 to the next day night 12. Likewise, you have to take some prescribed period of time. Okay, or maybe from Monday to Sunday. Likewise, you have to take upon a data based upon that you can calculate the load factor. So average load and peak load both should be taken for calculating the load factor. So load factor, a power plant should be high, so the total capacity of the plant is utilized for maximum period, that will result to in lower cost of the electricity being generated. It always less than unity. So you have to keep in mind, always the load factor should be less than unity. Why I am telling less than unity? Because then only we can able to supply the power without any trouble. Okay, if it is more than unity means we cannot able to supply. Okay, so it always less than unity. Okay, your average load and maximum load value. Okay, if you put it calculate the load factor, that will be equal or less than unity. That means less than 1. Okay, that is the meaning. So this is very important information. You have to keep it. So high load factor is desirable quality. High load factor means greater average load resulting greater number of power units generated. That is the meaning. So if it is more than 1.5, okay, I already told it may be equal to 1 or less than 1. If it is more than 1 point something means okay, that resulting greater number of power units is generated for given maximum demand. That means more amount of power is required. So you have to develop more power generation. That is the meaning. Okay. That means demand is high, maximum demand is there, but your supply is very less. Okay, that is the indication. Thus, the fixed cost which is proportional to the maximum demand can be distributed over a great number of units. So ultimately, what it indicate means if your value is greater than unity means okay, the load factor value is greater than unity means it indicates okay the power generation unit should be increased. That also indicates okay the fixed cost uh, of power plant also it increase. That is the meaning. Okay, that means you have to additionally add some money for producing the power. That means you have to generate power means you have to develop another power plant. That is the meaning. Okay, so this is the thing you have to keep in mind for load factor. Right. Next factor is utility factor. So what is utility factor? It is the ratio of unit of electricity generated per year to the capacity of the plant. So it is a ratio. Okay, how much electricity generated per year divided by capacity of the plant. So for an example, okay, in a thermal power plant, we can able to produce 230 volt megawatt. Okay, in particular year. Okay, so what will be the utility factor means? It is the ratio of electricity generated per year. So per year we are generating 230 and the capacity of the plant may be, it is maybe high 250 megawatt. So 230 is the actual power produced per year and capacity of the thermal power plant is 250 mean. Okay, 230 divided by 250 is nothing but utility factor. So according to the based upon the power plant capacity and the amount of power generated per year, we can calculate the utility factor. So you have to put the ratio of these two parameters. Okay. It can also be defined as the ratio of maximum demand of the plant to the rated capacity of the plant. Supposing the rated capacity of the plant is 200 megawatt, the maximum load of the plant is 100 megawatt, then load factor is 80%. How we can calculate 80%? Okay, so 100 into 0.8 போட்டு 200 போட்டால் that is the utility factor நம்மளுக்கு கிடைக்கும். அதாவது 80% தான் maximum we can produce from this plant. Okay, so the capacity of the plant is 200 megawatt, but producing capacity வந்து பார்த்தீங்கன்னா 100 megawatt, that is nothing but 80%. So how we can calculate utility factor? So utility factor is nothing but the ratio of amount power or amount of electricity generated per year divided by capacity of the plant. So utility factor calculate பண்ணனும்னா you have to take these two parameters, that is 100 megawatt we are producing. Okay, so the percentage பார்த்தோம்னா 80, so you have to multiply 100 into 0.8 then divided by the capacity of the plant is nothing but 200 megawatt, so divided by 200 போட்டோம்னா the utility factor is 40%. So 40% utilize the plant and we are producing 100 megawatt in the capacity of 200 megawatt plant. That is the meaning. So this is the way we can calculate the utility factor. Some other factors are plant operating factor, plant capacity factor, and demand factor, diversity factor also there. So that will be the, and some other factor, some other curve also we are going to discuss. That is load curve, load duration curve, dump curve, foam curve, prime power, and hot reserve, spinning reserve. So these are the things. Okay, we will see in the next class. So up to this we covered. So what is meant by types of load? What is meant by load? Load is nothing but requirement of power. So based upon the requirement, we are classified into 6 different types. What is meant by load curve we discussed. After that, how we can draw the load curve based upon the time duration, and based upon that we can able to calculate the what will be the demand, what will be the power supply, what will be the capacity of the power that will be calculated easily. And finally we discuss about terms and factors. In that we discuss about what is meant by character load, and finally we discuss about demand and maximum peak demand and load factor and utility factor. Okay, so in the next class the remaining factors we are going to discuss. Up to this, you have any doubt?
No, sir.
Students? Okay, right. So next class we will see the remaining factors. Okay. So now you can leave. Thanks for watching. Thanks for your comments. And Madan Prasad, sorry, and Venkatraman kindly send the alternates. Okay.
Okay. Thank you, sir.